Hello and good afternoon to all of you. I hope all of you are doing well. So, in today's class, we're going to learn about different types of design. So, if you remember in the previous class, we've learned about what is design, we've learned about different phases in design, we've learned about the significance of high level design and architectural design. We've learned about various design concepts and we've learned about various design considerations. So, in today's class, we're going to learn about different types of architecture. So we can have a function-oriented architecture or object-oriented architecture or service-oriented architecture being pursued for a given system. So function-oriented architecture or selection of architecture prior to that, selection of architecture basically depends on the state of the system's information and whether you're building a monolithic or a distributed system. So, for an example, in situation where the procedures are readily available, then what we can do is we can use function-oriented architecture. If the procedures are not readily available and we have only an idea about the objects, then you can pursue object-oriented architecture. So, depending upon the state of the information about the state information about the system and the nature of the system, whether it's a monolithic system or a distributed system, you can select any of the architectures, right? So let us try to focus on function-oriented architecture. So in case of function-oriented architecture, the system is perceived as a collection of interacting functions, or system is decomposed as a collection of interacting functions where the overall state information is centralized. Now, what does it basically mean? Here, in case of function-oriented architecture, you implement a system as a collection of interacting function with the information content of the system being centrally placed. Now, there are several disadvantages of having such kind of orientation. The first disadvantage is that since the overall state information is centralized, all the functions have an access to the central data store, making the central data store vulnerable. Right? Okay. So each and every function can have an access to the central data store, and any intentional or unintentional change brought to about in the central data store may result in other functions exhibiting behavior in an abnormal manner, right? So that may be one of the consequences of centralizing the data store. Now, in case of function-oriented architecture, the functions can maintain their own local information as well, right? But the local information can be present will be present only during the execution of the program, right? So this is very much true. So function-oriented architecture considers the way how the algorithm is implemented, but it does not protect the data. That is one of the major limitations. So this causes the problem because a function can change the state in a way that other functions do not expect. So change to a function and the way in which it uses the system state information may cause an unanticipated change in the behavior of other functions. So that is what we were trying to focus on. So this is one of the major limitations of function-oriented architecture. So this implies that function-oriented architecture is only suitable in situations where the information content is very limited, right? Okay, or the overall state information is very limited, or there is an explicit mechanism for expressing information sharing. Okay, right? So these are the situations where what we can do is we can put to use function-oriented approach. Now, let us create a very basic distinction between object-oriented approach and function-oriented approach. In case of function-oriented design, the overall state information is centralized and a system is perceived as a collection of interacting functions. Whereas in case of object-oriented design, the overall state information is decentralized and the system is perceived as a collection of interacting objects. Okay, so just see that is the difference. In case of FOD, system is perceived as a collection of interacting functions and the state information is centralized. In case of OOD, state information is decentralized and system is perceived as a collection of interacting objects. That implies in FOD, emphasis is given on function, in OOD, emphasis is given on data, right? Again. The other disadvantage of other difference is that in case of FOD, since the overall state information is centralized, central information is rather vulnerable to attacks, right? Okay, or maybe so any function that wants to bring about a change to centralized state information can bring about a change leading to other functions behaving unexpectedly. Whereas in case of OOD, since the data is decentralized and the way how the data and the functions implemented is concealed, so other objects do not have an access to to other objects. Data and member functions. So here, what we are doing is we are providing security, thus promoting integrity. So in case of OOD, we have additional features like inheritance, polymorphism, encapsulation, dynamic binding, right? Okay, so on and so forth, that makes it much more suitable for situation where what we need to do is we need to work with large volume of data, right? Again, and we need to preserve in the integrity of the data. Now let us try to move on and discuss some of the important design concept that is called as coupling and cohesion, right? Now coupling basically refers to degree of dependency between various modules, right? Okay, so it is a intermodule dependency, right? Okay, so there are different ways in modules may depend with each other. So a highly coupled module may be highly undesirable, right? Because reusability of such module is very low. So we need to organize a system as a collection of modules where modules interact with each other with a minimum amount of information, or there is a very low degree of coupling. So coupling in case of computation science is the dependency or the degree of dependency between program modules. You see, so coupling in case of computational science is the degree of dependency between the program modules. So it is in contrast with cohesion, where cohesion stands for functional strength of a module, right? Okay, cohesion stands for functional strength of a module, so it's an intra-module concept. So coupling is the intermodule and cohesion is the intramodule. So coupling basically refers to degree of dependency, and cohesion basically refers to the competence of a given function or functional strength of a particular module. Now, there are different ways in which a module can depend upon another module. It may be for a simple integer variable, maybe for a complex variable like array, or maybe for internal working. So there are different types of coupling that may exist between different modules that are there in a particular program. So just see, low coupling is often a sign of well-structured computer program and a good design, right? Combined and when combined with high cohesion, so what it enables high readability and maintainability and reusability, right? Again, so whenever you build up your or whenever you formulate a design for your software system, it should exhibit very low coupling and very high cohesion. So type of coupling. So there are different types of coupling. So we have content coupling, we have common coupling, we have external coupling, right? We have control coupling, we have stamp coupling, we have data coupling, right? Okay. We have message coupling, we have no coupling, right? Okay. We have subclass coupling in case of object-oriented programming, and temporal coupling, right? So, so we'll discuss each of the coupling in detail. Now let us try to understand what is content coupling. So content coupling is when one module modifies or relies on the internal working of another module. Okay, so this is very much important. So content coupling basically refers to a situation where a module depends on the internal working or relies or modifies or it so content coupling is when one module modifies or relies on the internal working of another module, right? So this is called as content coupling. Therefore, changing the way how the second module produces data, subsequent change may be reflected on the dependent module as well. Now, common coupling. Common coupling basically refers to a situation where two modules share some same global data, right? Okay. So common coupling is a situation where two modules are related with each other with the help of a common global data, right? Now, external coupling. External coupling basically refers to a situation where two modules share some externally imposed data format or communication protocol or device interface. And this is called as external coupling. Now we have control coupling. Control coupling basically means a situation where one module controls the flow of another. by passing information to it, right? Again, so control coupling is a coupling where one module tries to control the flow of execution of another module on another module by passing information onto what to do, right? Now next one is stamp coupling. So stamp coupling is a situation where a module depends upon another module for a composite data structure like an array or a record, right? Okay, so this is in this situation, one module depends on another module for a composite data structure like an array or structure, right? Okay. And now data coupling. Data coupling basically refers to a situation where a module depends upon another module for a simple variable, right? Okay, or for simple variable, or as an example for simple integer value, right? Okay, so that is the difference between data coupling and stamp coupling. In case of stamp coupling, we work with data a composite data item, whereas in case of data coupling, we work with atomic data item, right? Message coupling, so this is the loosest type of coupling. It can be so here what happens is that two modules interact with each other or depend on each other for messages, right? Or they interact with each other by passing messages, as in case of object oriented programming, right? Now no coupling, so there is no dependency between two modules, right? So we have no coupling, we have message coupling, we have data coupling, stamp coupling, control coupling, content coupling, common coupling, and content coupling, right? So here again I'll repeat it. Content coupling, if there is a dependency between two modules in a manner that one module modifies or dictates the internal working of another module, that is called as content coupling. Common coupling, it refers to a situation where two modules depend on each other via a global variable, right? Okay. External coupling, they depend on each other, right? Or there is a dependency between modules based on externally imposed data format or communication protocol or device interfaces. Control coupling is dependency between the modules based on a situation where one module controls the flow of execution of another module. Stamp coupling, it refers to a situation where one module depends upon another module for a composite data item like an array. A data coupling refers to a situation where one module depends upon another module for a simple data item, right? Again, like an integer variable, integer value. Now, message coupling, this is a type of coupling where the modules interact with each other by passing messages, right? Again, no coupling, there is no dependency. Now what we need to do is we need to arrange it in order of their significance, right? So the most desirable form of coupling is called as message coupling, and the least desirable form of coupling is called as content coupling. So the most desired form of coupling is message coupling, where two modules interact with each other by passing messages, as in case of object-oriented programming, and the least desired form of coupling is called as content coupling. Now let us move on to the other classes of coupling associated with object-oriented programming, that call as subclass coupling and temporal coupling. So you can go through it, right? So subclass coupling basically describes the relationship between a child and a parent. The child is connected to its parent, but the parent isn't connected to its child, right? Temporal coupling, when two actions are bundled together in one module just because they happen at the same span of time. So that is the temporal coupling and the subclass coupling that you have. Now let us move on to cohesion. As I've said, in case of computational science, cohesion basically refers to the functional strength of a module. How functionally sound a module is in exhibiting behavior pertaining to the module, right? Okay. So cohesion is the measure of how strongly related the functionality expressed in the source code of a software module is. Now, a module can be a module is implemented as a collection of functions, right? Okay, where module has their own local data structure, right? Okay, so the functions that are there belonging in the module performs operations that are desired from that particular module, right? So cohesion basically refers to a situation where it reflects the functional strength of a module. That means how cohesively the functions inside the module are capable of realizing the expected behavior. So modules with high cohesion tends to be preferable because high cohesion is associated with several desirable traits such as robustness, reliability, reusability, and understandability. So these are important traits of cohesion that it exhibits. So highly cohesive modules are robust, reliable, reusable, and understandable. So cohesion is all used often in contrast with coupling. So it's a different concept, right? Okay. So there are different types of just see, you can go through the disadvantages of low cohesion, right? So now there are different types of cohesion here. So coincidental cohesion, logical, temporal, procedural, communicational, sequential, and functional. Now, just see, let's go through each of the cohesion in a little bit detail. So as you've already studied, cohesion is the functional strength of a module or the strength of a particular module in exhibiting desired behavior. So behaviors are exhibited by the functions that are there inside the module, right? So coincidental cohesion basically refers to a situation where functions are coincidentally included in the module, right? Okay. So coincidental cohesion is when part of the modules are grouped arbitrarily. The only relation between them is that they are grouped together. Say, for an example, a situation where the functions are placed inside a module without having any relationship between them. So that's purely coincidental, right? Okay. Now this is one of the least desired kind of cohesion. Now logical cohesion. Logical cohesion is a cohesion that refers to a situation where where the functions in a particular module exhibit similar behavior, right? Again, it's a part of modular group because they are logically categorized to same thing, right? So, an example, all the functions that are there in the module are capable of reading, so that is not desired. Okay, right? All the functions that are capable of displaying, that's not desired. So that is what is called as logical cohesion. A type of cohesion that is encountered because of the grouping of the function based on their logical abilities, right? Now, temporal cohesion. Temporal cohesion basically refers to a situation where the functions are included in the module because of the fact that they are executed within a given particular timestamp. Right. Okay. So temporal cohesion is a part of is when part of the modules are grouped by one when they are to be processed. The part are processed at a particular time in the program execution. So this is what happens. Right. Okay. So this is called as temporal cohesion. So they are related by the fact that they are to be executed at a given span of time. Now, procedural cohesion. Now, procedural cohesion is a cohesion when the part of the modules are grouped together because they always follow a certain sequence of execution. This is called as procedural cohesion, or they follow certain sequence of procedure. So, an example, a file which checks the file permission and a function that checks in the file permission and then opens the file, right? Again. Now, communicational cohesion. Communication cohesion exists when the parts of the modules are grouped because they operate on same data, right? That's called as communicational cohesion. So, for example, a record, right? A file that it accesses in order to perform operation. Now, sequential cohesion. Sequential cohesion is when parts of the modules are grouped because output from one part will act as input to another part, right? Okay? Like in case of assembly line where one output from one function will act as an input to another function, right? Now, functional cohesion. This functional cohesion is a cohesion where a part of the modules are grouped together because they all contribute to a single well-defined task. So this is very much important, right? Okay. So all functions that are there in the module should collaboratively realize a given specific task. So these are the different types of cohesions that you have. You have coincidental, you have logical, you have temporal, you have communicational, you have procedural, you have sequential, you have functional. So functional cohesion is the most desired, whereas coincidental cohesion is the least desired or the least desired one, right? So what we have learned is we have learned what is cohesion, we have learned different types of cohesion and the desired and the least desired cohesion. Now let us try to understand some of the good characteristics of software design. Now some of the good characteristics of software design, so it can be categorized into operational, transitional, and maintenance. Okay, right? So in the transitional field, what we have is uh, budget, right? Okay, so good design should be capable of reducing the overall cost of implementation. It should be usable. It should be efficient. It has to be correct. It has to have express all the functionalities. It has to be dependable. It has to be secure. It has to be safe, right? Okay, and transitional. It has to be portable. It has to be interoperable. It has to be reusable. It has to be adaptable. Maintenance related, so it has to be modular in orientation, right? Again, it has to exhibit maintainability. It has to be flexible and it has to be scalable. Now, in today's class, what we've learned about is we have learned about function-oriented architecture, right? Again, we have learned about some of the important aspects of function-oriented architecture. Then we have differentiated between object-oriented and function-oriented architecture. We have learned what is coupling. We have learned different types of coupling. We have learned the desired version of coupling, right? Okay, and then we moved on to cohesion. We've learned the importance of cohesion, right? We've learned different types of cohesion, and we've learned about different types of goodness criteria that a design should exhibit, which is divided into operational, transitional, and maintenance, right? Okay, so this ends our fifth chapter, that is design. So in this chapter, what we have learned about is we have learned about what is design. We have learned about what are different types, different phases in design. We have learned about high level design and low level design. We have learned about different design considerations. We have learned about different design concepts. Then we have learned about types of design where we try to emphasize on function oriented design. We differentiated object oriented design and uh, function oriented design. Then we dealt with coupling. We learned about different types of coupling. Then we dealt with cohesion, and we tried to understand different types of cohesion. So thank you very much. Have a very good day.